be more concrete and establish a mathematical framework, as vectors which can only exist when we assume an arrow of time. They can be derived as resonance and interference with the reference frame, which defines the minimum unit or space-time constant c, equivalent to the constant of Planck in quantum mechanics. Experiments show how conversion of matter into energy through its antimatter brings about gamma rays with exact opposite momentum. What seems to be a conversion is the ratio between opposite vectors interpreted as distance and time, matter and antimatter, mass and energy, or interference and resonance within the abstract arrow of time of c. The sum of opposite vectors is always zero. This is the reason for the symmetry or conservation laws in physics, or why at the speed of c, time and space are zero due to length contraction and time dilation. A consequence is the Heisenberg uncertainty principle, which states that certain pairs of physical properties, such as position and momentum, cannot be known simultaneously to high precision. In a sense, a single particle is its own field. This does not explain our sense of continuity, where c cancels itself out within its own required interval. But when these vectors are exponentially amplified or accelerated relative to and within the abstract arrow of time, the underlying mathematical algorithms, also describing the fundamental forces, can bring about a consistent reality and have abstract building blocks. This is why the harmonic motion equations are used in many fields of physics involving periodic phenomena, such as quantum mechanics and electrodynamics, or why Einstein's equivalence principle, used to derive the model of spacetime, states that there is no difference between gravity and acceleration. Because gravity is only a force when interpreted relative to an oscillating frame of reference. This can be illustrated with a logarithmic spiral curve being reduced to a helix curve by the reference frame, making objects spin and move in orbits. Visually simplified, two amplified or growing apples will be interpreted to attract each other when observed by an amplified reference frame, as the size seems unaffected. The opposite occurs with interference. In a simplified analogy, the increase or decrease in the size of objects as we get closer or further away is determined by the shift in vectors of the reference frame, similar to how a radio hones in on different waves to pick up radio stations. This also applies to the influence of gravity. In essence, independently of any reference frame, there are no fundamental forces. All interactions within our abstract continuity can be mathematically derived through interference and resonance as long as the ever-changing and fluctuating minimum unit or quantum, being the frame of reference, is taken into account. Experimental evidence includes the unseen effect in the standard model, where we can see the force effect, but not the actual force carriers. The consistent continuity of reality does not require quanta to have any specific sequence in time. A quantum is not subject to any notion of space or time and can occupy all of its possible quantum states simultaneously. This is called quantum superposition and has been demonstrated in experiments such as the double-slit experiment or quantum teleportation, where every electron in the universe, for example, could be the exact same one. The only requirement for an abstract arrow of time and consistent continuity or reality is the algorithm describing the pattern or abstract sequence of vectors. Since this continuity brings about our ability to be self-aware, it inherently makes us subject to its mathematical consequences, the fundamental laws of physics. Interaction is merely an interpretation of what is essentially an abstract pattern. This is why quantum